Hello friends, we have LED and switch interface project with 8051 microcontroller. This is 8051. Some indeed components for this: crystal oscillator, resonant capacitor of 33 picofarad. This crystal can be used from 4 MHz to 12 MHz as per requirement. 10 kilo ohm resistor as reset resistor, reset switch, reset capacitor connected in reverse polarity with reset and positive line. So the positive is connected with VCC supply, while negative of the capacitor is connected with pin number 9, that is reset pin. All the LEDs are connected in forward bias condition and they are connected at port P2. These are active low switches, push to on switches. These are connected with port P1. This is buzzer for indicating that any one of the switches is pressed. Until we pressed the switch, until we release the switch, this buzzer will be on. It will be drive with help of this transistor because this microcontroller cannot drive a current more than 40 milliampere, while this buzzer needs at least 200 milliampere. So we have to use this transistor as amplifier or as a switch. When microcontroller send a positive data, a forward bias current, a positive current, this is fed to the transistor with base connection, and the collector emitter junction will be on. The buzzer will get positive from direct adapter. This is adapter connection. The positive will come directly to buzzer and negative will come from this line. So we are using this transistor to drive this buzzer. You can use 5 volt, 12 volt or 6 volt buzzer. Please connect this positive line according to that requirement. LED is connected with port 2 with forward bias condition. Resistor is connected between port 2 and LED, while negative of this LED is directly connected to negative supply, which is here. Reset switch will not work in Protus. This is limit. Now we will see the presentation of this project. When we play it, positive supply is coming from here. It is protected by this diode D6, so the negative supply cannot here, so the reverse polarity is rectified. Or you can give a AC supply 12 volt also. This is filter to filter this power supply. Regulated 5 volt will be available here with help of 7805. 12 volt will be converted to regulated 5 volt with this 7805. Second number pin is ground, first number pin is input, while third number pin is output. It is fed to supply pin, and 40 number pin is hidden in Protus. Also a 20 number pin, that is ground, is also hidden. The positive 12 volt is available directly here at buzzer, while negative is available with help of this emitter collector junction, but it is off now. When we press any one of these switches, the microcontroller will detect that any one of the switches is pressed, and it will convert this low level pin to high level logic. It is fed to this line and the base will get a positive signal and it will drive the buzzer. Let us see the difference. When we press any one of the switch, see difference here. Yes, the buzzer works. So any one of the switch is pressed, the buzzer will give us audible notice that any one of switch is pressed, but we have to know which switch is pressed. So we have used here LEDs. The program will remain the LED on until we reset the system, or we press another switch, but when we press another switch, buzzer will be sound. The sound will come from a buzzer. Let us see again. Switch 1, 2, 3 and 4. The 4 number LED is on. Switch 3, switch 2, switch 1. Okay, this the project works. See the line, this is positive, these all are negative, and negative is coming here, so the LED is off. Only this LED is on because of potential difference. Now this difference is available here. See the supply. Now we will see the code. This code here we have include header file for 8051. It is required. The pin of LEDs, buzzer and switches are defined with S-bit function. Port 2 bit 6 is connected as LED 1. All the details are available in the comment. This must be done before the program starts. The main program starts from here, that is void main. First of all, when we start the project or reset the project, only these two lines will be executed once. After reaching to this when the counter reaches here in while loop, which is loop forever, endless loop, these lines are not executed. It will be executed only once when we reset. So you can say setup or starting condition, initial condition, buzzer LED 1, LED 2, LED 3 and LED 4 pin 0. So the logic of that pins will be remain 0 until the next statement or next command. Switch 1, switch 2, switch 3 and switch 4 are internally high to detect pressing of switch. After that the counter will come to here and this portion will executed forever until we stop the project or reset the switch. So things between these two bracket will be executed ever. If switch 1 is not pressed and switch 2 is not pressed and switch 3 is not pressed and switch 4 is not pressed, so none of the switches are pressed, buzzer will remain off. Else means if switch 1 is pressed or 2 or 3 or 3 or 4, any one of these 4 switches are pressed, buzzer will not remain 0, it will remain high, so buzzer is high. Now we have to know which switch is pressed, so we have to indicate that by LED. So we have written the code here. If switch 1 is pressed, so pressed means the status of this switch is equal to 0, because if we press this switch, this pin is internally high, but when we press it the status will be 0. You can see if we not press the switch it is red, when we press the switch it remains 0. The same for different switch. So microcontroller detects that the switch is pressed or not. So microcontroller gets the information about switch, that which switch is pressed or it is pressed or not. If switch 1 is equal to pressed, the status of SW is equal to 0. 2, 3 and 4 are not pressed, so the status of that switches will be remain high, logical high signal, it means 1, 5 volt. Then if switch 1 is equal to 0 means switch 1 is equal to pressed, L1, L2, L3, L4 are 0 initially, then it will start LED 1 by giving signal of high level. It means 1. So the 5 volt is coming from that LED 1 pin. Let us see. This is LED 1. All are 0. All pins are 0. If we press switch 1, switch 1 is here. See the difference. If we have pressed a switch, 5 volt is coming here until we press another switch. The 5 volt be there. It is not going to 0 until another switch is pressed. So if we press switch 2 or switch 3, what happened? Switch 1 is not pressed, switch 2 is not pressed, switch 3 is equal to pressed, and switch 4 is equal to not pressed. All the LEDs will be 0. L1, L2, L3, L4 are 0. Only L1 again go to 1. So if we press switch 3, LED 3 will be high. Same for switch 4. Basically this is very simple project or simple program just to demonstrate how to work with LED or how to work with IO port of 8051 microcontroller, and how to work with switches and how to detect switches with 8051 microcontroller. This project is made by, or a tutorial made by, 123 projects. My name is Jay. If you like this video, please subscribe our channel and send us request if you want another tutorial. When we get the time, we will upload that tutorial. Please do not ask for free help. Sorry for that, but we are not giving that way. We are in business. Thanks for watching. Jai Hind.